All right, welcome to part 2 of the wall hugging tutorial. So we're just going to continue right where we left off. Um, One thing we want to fix real quick, if we go into our find closest wall function, or sorry, if we go into our line trace function, you'll notice that we have this set to visibility for the trace channel. So this is okay, but it's going to run into problems because basically it's doing the line trace on anything that's visible in your game, like other players or potentially weapons, right? So we don't want the line trace when we're looking for walls to hit things like that. And the only other option here is camera, which isn't great because that's the one that the camera uses. That doesn't make sense. So we're actually going to make our own trace channel just for this, and that way it only hits things that we want it to hit. So if we go up to our project settings and we go on the left to collision, you can see we can add our own trace channels here. So we're actually going to do that. So if we hit new trace channel, we're going to call it the wall trace. And then the default response is ignore. And that's just saying like, for anything we don't have set, just ignore this, or this trace should just ignore things. Because that's what we mostly want it to do. We mostly want it to ignore things, except for walls, right? So we're going to hit accept. And then down here in the presets, we just want to update these to account for our new trace channel. So if we go to collision, or sorry, if we go to the no collision one by double clicking on it, this one's correct. You can see we have our wall trace here. We want to make sure it's set to ignore. We just need to go through a few of these to make sure they're all okay. So block all, we want to say block all. Overlap all, we want to do overlap all. We just kind of want to follow the standard that they have for all of these. Like so. I'm just going down the list here. I'm just setting them to what they are before. Overlap only pawn. So overlap only pawn, yes, we want to ignore. And then I think that's all we need to do. So if you look at like pawn here, this is what our player is set to. Our player is a pawn. You can see the wall trace is set to ignore pawns, right? So now it's going to ignore like characters and stuff like that. It's only going to hit like, things that are set to block all, which is probably going to be walls. You might have to do a little bit more based on your project. You might need to adjust those settings if you have some. It's hard to say exactly what you want your trace channel to be. For the purpose of this tutorial, we're gonna just set it to. We might need to refresh this. Yeah, there it is, wall trace. So if you right click and refresh this node, your wall trace will show up. We want to switch it to that. So this is definitely good enough for this tutorial. But if you're doing like more stuff in your game and you have some other type of objects that you want it to specifically ignore, like eventually you'll need to set it up so that in the settings it ignores those specific type of objects, right? Okay, so I just wanted to point that out. So we should be good. Let me make sure this still works. So if we press play, it still should hit. Like you should still see those little red squares that pop up on the wall when it hits it, which is good. Okay, so now let's continue with the actual logic. Let me go back. Let's see, where did I leave off? So we left off in our line trace function. So this function, we actually want to return these two parameters. So an easy way to do this, if you just take the out hit and just drag it back to the start, it will give you an option to add the pin. And so if you just release, it will add it like so. And we can hook that up. And we want to do the same for here. So we'll hook that up. And there we go. So we got our two outputs. And so now we can go back to our find closest wall function. And what we want to do is we want to do a branch to check if it hits something. And so if the line trace hits something, then we want to check, like I was saying before, we want to check if it is the closest, or if it's like the shortest distance line that we found. Because in the case where you're hitting multiple walls with line traces, we want to make sure that we're starting the wall hug with whatever wall is closest to us. So we want to do a branch, and we want to actually break this because we want to look at the distance primarily. So we want to drag off the distance, and we're actually going to promote this to a local variable as well. If you remember on the left, we actually made some local variables already to keep track of the closest wall distance, the closest wall location, and the closest wall normal. We actually want to make 3 more variables that mirror these variables, but they're going to be our current ones. So we're going to always be comparing our current distance to our best distance and checking if it's better. And if it is better, we're going to update it. So we can just right click on this and say duplicate, duplicate, and duplicate. So duplicate each one of those, and then we're just going to rename them to, instead of closest at the beginning, we're going to call them current, and just do that for each one. Current, and current. Okay, so what we're going to do here, and make sure you get this correct, because I know they kind of look similar, current and closest, but really pay attention here, like don't mess this up, because otherwise it won't work. So we want to set the current wall distance, not closest, current wall distance to our distance here, because this is the line we are currently on, right? Because we're inside of a for loop here. So this is the line trace that we're currently looking at. And they also want to set the current wall location. So drag in current wall location and say set, and we're going to hook that up to location, and then drag in the current wall normal and set that to the normal. Again, make sure you're using current here for each one of these and that you have them set up exactly like I do here. And so now we have all of our current values set. We want to compare them to the closest ones or the best ones, right? So what we're going to say is we want to say, is the current wall distance, so drag in the current wall distance, is this guy less? Oh, see, I keep doing this. So it's not float less than anymore. It is, you just type less and then it pops up. So if this is less than our closest wall distance, then it is a winner, right? So this is the guy we want now. So we're going to do a, well, actually, we want to check one more thing. So we're going to do an or boolean. So if it's less than the closest, or if we don't have a closest yet, right? So this is like the first iteration of this loop. And to check that, we can just check if our closest wall normal is 0. So is 0 vector. So this is basically saying, is this current line trace the shortest line we found so far, or is this the first line trace we're doing? Because if it's the first one, we want to keep it no matter what. Then we're going to drag off of this to a branch. And so I'm just going to add a little comment here. So this is saying, like, you know, is this line trace the shortest one so far? So that's essentially what this is checking. Is it the shortest one so far? And if it is, then we want to update all of our closest values to match our current values. So we'll say closest wall distance. We're going to set that to our current wall distance. And we're going to say closest wall location. We're going to set that to our current wall location. And finally, closest wall normal. We're going to set that to our current wall normal. And that's all we need to do. So again, make sure you did this part correctly. Make sure you have closest up here on this row and current down here on this row, and that you have location, location, and normal, normal all hooked up. And double check this, because I've done things like this in other tutorials, and people, when they mess up, they usually mess up here and they get these backwards. So really important, just make sure that this is correct. Okay, so I think we're good. So now you can see, if we remember when we wrote this function a while ago, we have a sequence node right here at the beginning. So no matter what happens inside of this for loop, it's eventually going to return all of our closest values, right? Which is what we want. So now we can come back to our try begin wall run function. And we want to check if the wall was found, right? Because if we press the button to start a wall hug, but there's not a wall near us and we didn't find one, then there's really nothing for us to do. So that's why we're checking this before we continue. And so if this returns true, that means we found a wall that we can wall hug. And so what we want to do is we want to save these values. So we're going to take this guy, this wall location, and we're going to promote this to a variable. Make sure you hit variable and not local variable, because we're actually going to need this in other functions. So we're going to promote it to a variable, hook this guy up to the true, and then I'm going to call this, I'm going to rename this to the move to wall end, and you'll see why I'm calling that in a second, but this is essentially where we want our character to move to, right? Because this is the location of the wall. This is the end location of our character. And then we also want to save where we're starting from. So we're going to say get owning character, get actor location, and we're going to call this guy, or right click on this guy and promote him to a variable as well. And we will call him move to wall begin. So we have move to wall begin and move to wall end. So these values just keep track of where our character is starting from and where we want him to end at. So just to give you a refresher, this is my other project. So when we press E here, it saves where he is and it saves where he needs to move to, because you'll notice when I press it, he actually moves. He moved to the wall. So that's what those two values are. That's where he starts from and where he ends at. And we're kind of going to interpolate between them. And just to keep things a little bit more organized here, I'm actually going to, because we're going to be adding a few more variables here. So let's actually take this move to wall end and let's add it to a category. So down here, let's just add it to a category. I'm going to call it move to wall, because all these variables that we're about to add are related to moving to the wall. And then we're also going to make this private. And then we're going to drag our move to wall begin inside of here as well. And we are going to make it private. I'm going to drag this on top. So begin happens before end. It doesn't actually matter. I just like it organized that way. We also want another variable. So let's see. So both these are private. So let's right click on this end guy and just duplicate him. And that's just going to keep the private checkbox checked. And it's also going to keep us in the category. And then we're going to call this move to wall time. And we're going to make this a float. And you'll see what this is going to do in a second. This is basically just keeping track of the current time we are inside of our move, because we want to move to the wall in like a half a second, right? Or some amount of time. We don't want to take too long to get to the wall. We want it to happen pretty fast. So this variable just keeps track of what time we currently are inside of that interpolation period. And then also we want a move to wall rotation begin and a move to wall rotation end, because if you remember, our character actually rotates so his back is facing the wall. So we want to save those two values as well. So I'm just going to make those real quick. So let's just right click, duplicate this guy, move to wall rot for rotation begin. And we're going to change this to a rotation value or a rotator, and then duplicate this guy. And then instead of end, we'll say begin. So we just want to set time rot begin and rot end, because we already set these guys. So for rotation begin, it's simply just going to be our character's rotation. So copy this guy, say get actor rotation, and then set this to the beginning rotation, because that's what his current rotation is. And then his ending location, or sorry, his ending rotation, we want his rotation to be such that he's rotated so he's facing away from the wall, right? So for end location, let's drag, or end rotation rather, drag this guy in. And then we can actually calculate this value based on the normal of the wall. So if we take the wall's normal, we drag this over here, we can say make rot, which is rotation, from ZX. So the reason we're choosing this one is because if you don't know how these work, I'll try to explain this because people always ask me about this. But if you search for make rotation, there's a bunch of different options here. And the best way that I've come to understand it is I always use the ones that have two values in them. So whatever value, let me try to think of how to explain this. Well, let's just look at this one. So this one says ZX. So the whatever number or whichever letter comes first here, so in this case it's Z, that's the axis that you absolutely do not want to change. And so in this case, we want this to be vector up. And so the reason we're saying we want this to be vector up is because we want his Z vector to always be up, right? We don't want our character's Z vector to be anything other than directly up. Otherwise, he'll start rotating weirdly and he won't look like he's standing up. So we're saying, like, uncompromisable, the Z value has to be vector up. So whichever one comes first here is the one that will absolutely not ever change. The other value can potentially change, just the way like rotations work. But we want to say X because X is the direction we want him to face. And so we want him to face whatever way the wall's facing. So that's why we're using the wall normal. I don't know if that made any sense or not, but you can probably look this up to get a better explanation. But basically, just give us a rotation from these two vectors. So we're saying up vector is up, and his forward vector is whatever way the wall is facing. We're saying that's the way we want our character to face. Okay, so that's going to go inside of here. And then finally, we want to set, we just want to reset the move to wall time. So we want to set this down to 0 because we're just starting it. And then we're going to increment this over time as we're moving to the wall. And then the next thing we want to do is we want to set the wall hug state. So drag this guy in. And so of course we're going to set him to moving to wall because that's what he's about to do. He's about to move to the wall. And then what? Oh, so this is like a stupid error. You just need to change the default value to something other than 0, and then you can set it back to 0, and then Unreal is totally fine. I don't know why that's a thing, but it's a thing. Okay, so now we've done that. So now we want to say owning character. We want to change it so that our owning character no longer orients to... Actually, let's just leave it off so you can see what it does. Okay. Let's see here. Let's just, let me see, sorry, I forgot where I did. Oh yeah, so at the beginning we made a sequence node and we returned false by default. So we're gonna copy this and then all the way on the right here. So if we get all the way over here, then we wanna return true. And this is why I like doing this, because if this line of logic fails here, or if it fails here or here, it's gonna return false. So we don't have to hook up falses to here, and a false to here. Instead, we can just do one sequence node at the beginning and return false by default. And then if it happens to get all the way through everything and everything's good, then it returns true. So it's just like a much easier way to handle return values, in my opinion. Okay, now I'm lost, hold on. Try begin wall hug. So let's see, hold on, sorry. I don't think anything's going to change if we play it because we don't actually have anything set up. So he's technically in this move to wall hug state, but nothing's actually happened yet. So we need to write our tick function so that things actually start happening. So let's go to our event graph, and then let's see here. Let's add an event tick. And then we want to do a switch statement here right at the beginning because we want to do different things depending on which state of the wall hug he's currently in. So we're going to do a switch. So if he's in none, meaning he's not actually wall hugging anything, then obviously we don't want to do anything. So we're just going to leave that one unhooked up. And then we want to make two functions here on the left to handle when he's moving to the wall and when he's on the wall. So we make a function and we're going to call it tick moving to wall. And we just want to take in the delta seconds since it's a tick function. So delta seconds. And then we can make this private. And I'm just going to duplicate this guy and we're going to call it tick on wall. And then we can come back here and we can hook these guys up. So tick moving to wall and tick on wall. And then the delta seconds, we want to pass this along to both of them, like so. And so now basically you can see what's going on. So when the tick calls, it does a switch statement, and then it calls this function if we are moving to the wall, and it calls this function if we are actually on the wall. So we need to write this function first, because that's the state we just put him into, if you remember back in try begin wall run. If it gets all the way to the end, it sets it to moving to wall, and so it's going to start calling this function. So let's actually go inside of here and start writing this. So what we want to do, if you remember, we made these values over here inside of our move to wall category. So we want to use these values to interpolate him from the begin to the end. So this is going to move his location from here to here. And we also want to move his rotation from what it currently is to where it needs to be. So that's why we have begin and end for each one of these. So the first thing we want to do is we want to take our delta seconds, which is how much time has elapsed between the frames. And we want to do so again, normally you can just type float divide here, but in the newest version, you have to just type divide, and then it will show up. And we want to divide it by however fast we want this interpolation to happen. So what I'm going to do here is I'm going to make this a variable, and I'm going to drag it into our move to wall category. And I'm actually going to add a subcategory to this. So to do that, if you hold down Shift and then you hit the backslash, which is the button below the backspace, it makes a vertical bar. It kind of looks like an L, but it's a vertical bar. And then we want to type move to wall speed. You'll see what that does is it actually makes a subcategory over here underneath this category. And then, oh wait, why did I call it? Sorry, this should not be called this. Sorry, click on this guy. I didn't mean to call that category this. Call this category constants. I wanted to call the variable that. Constants. And then we'll call the variable move to wall speed. Sorry. So it should look like this. So we have the move to wall category, and then inside of that we have constants. and then we have this move to wall speed. And the reason we're making this a constants category is because we're going to make this a blueprint read-only variable. We can also set it to private. So it's basically just a constant variable, right? It's just some setting we want to be able to set once before the game starts, and it never actually changes after the game starts. Unlike these variables that all change, throughout the game, like they get set and unset and adjusted as the game running. This variable is blueprint read-only, which means you can't actually change it. So you see if you drag this in, you try to set it, you can't. So when you ever have a variable like this where it's just controlling the speed of something and you just want to be able to adjust it easily, so you made a variable for it, it's really good to make it a blueprint read-only variable. And I like to just put it in a category called constant so it's easily distinguishable. But anyways, you can set this to whatever you want. I'm going to set this down to like 0.25, and then that's going to essentially make it so it will take him a quarter of a second to move to the wall. So the lower you put this, the faster he moves technically, which seems a little backwards, but it's basically, I guess it shouldn't be called speed. I guess it should be called move to wall duration, because it's how long it takes. So the lower you put this, the faster he'll move. So this is 0.25 seconds. Okay, sorry for the long tangent. Just wanted to explain that. So the next thing I want to do is we want to add to whatever the current value of this is. So we're going to take our move to wall time and add to it. And then we want to make sure this doesn't get above 1. So we're going to say clamp float between 0 and 1. And then we're going to set our move to wall time to that. So all this is doing is it's just taking this move to wall time variable and it's adding the delta seconds to it, but it's just scaling it based on whatever speed we want it to be. Okay, and then the next thing we want to do is we want to move him from his beginning location to his end location, but we want to do it smoothly, right? We don't want to just snap it. So we're going to use a function here called lerp, and then there's a bunch of different options. So you want to search for lerp vector, because we're specifically lerping a vector. Lerp stands for linear interpolate. You can see what it does here if you're not familiar with it. It basically just interpolates between the a and the b value based on alpha. So if alpha is 0, then a will be used. If alpha is 1, then b will be used. And if it's somewhere in between, it will interpolate between them smoothly. So our alpha is going to be this guy. Let me make a little reroute node here because we're going to need to use this other places. So alpha is going to be our whatever our time is, and then our begin is going to be A, and our end is going to be B. Pretty simple. And then we want to take this value and we want to set our actor's location to that value. So we'll say owning character, set actor location, like so. And that's his location. And then one thing that's very, very important, so do not miss it, is you want to select the sweep checkbox here, and that will make it so that if we're moving to the wall but we hit something, or we're moving up a ramp, your character will follow along the ramp, or he'll actually collide with the wall. If you don't have this checked, he'll kind of like awkwardly go through walls, and it won't be great. Okay, so that's our location interpolation. Now we want to do our rotation interpolation, which is going to be very similar. So we're going to say lerp, but this time we're going to say rotator because we're interpolating a rotator. And then our A is going to be our rotation begin. Our B is going to be our rotation end. Our alpha is going to be this guy, just like before. Move this up. And then just like we did over here, we want to say owning character, set actor rotation. Oops. There we go. That. And that is our rotation. And then the next thing we want to do is we want to check if this value has reached 1. Because if it's reached 1, that means we have finished the interpolation process and we are now officially attached to the wall. So we can check that very easily. We'll just say wall run time. Is this greater than or equal to? Make sure you do or equals to here, otherwise it will never work. So greater than or equal to 1. And then we'll do a branch. And if it is, then we want to set our wall run state to on the wall. Okay, so let's go ahead and give this a try. Let me make sure this is actually hooked up. Looks like it is. So we should see our character interpolate to the wall. But he's not going to get stuck on it yet because we haven't written that yet. But if we go over here to a wall and we press our button, you can see our character interpolates to the wall. We try to do it again, it's not going to work because he thinks we're still on the wall. But you can test it a few times to make sure it works on different wall types. If you're not next to any wall, it won't work, obviously. But if you're like facing away and then you hit it, your character will rotate correctly to face the wall. So just make sure that this is working correctly. If it isn't, go back and try to figure out where things went wrong. Because it's important that you have this working before we continue. Okay, so let's think here. I guess we can just start writing the tick on wall function next. So let's go inside of here. So this is going to start getting called as soon as that other function finishes, remember, because we just wrote over here, once this wall, or once this move to wall time gets to 1, which is when we're, totally interpolated to the wall, we're going to set the wall state to on wall. And then that's going to cause, remember, that's going to cause this to get called. So now we're inside of here. So this function only runs once we are, up against the wall. So inside of here, what we want to do is we want to make sure that the character continues to stay up against the wall, whether he's going across some little columns or maybe the wall's curving a little bit. We always want to make sure that the character is facing away from the wall and that his back is up against the wall. So those are the two things we want to essentially do inside of this function. So the first thing we want to do is we want to do a line trace to get information about the wall that's behind us, because the wall could change, right? Because if we go around a corner or whatever, the wall's always going to be changing behind us, or potentially always could change behind us. So each tick we need to figure out information about the wall behind us. So let's drag in our owning character, and we're going to do a line trace here. So we're going to say get actor location, and we're going to use this for a line trace, a new line trace. So let's say line trace, we'll just drag in this little function we wrote earlier, and we'll hook this up to the start. So that's the start location. And then the rotation angle, we can just put 180 here. And the reason we're putting 180 is because 180 is essentially behind us, right? So if we pass 0, the line trace would be going like forward in the direction we're facing. But we want to do it backwards, so it goes into the wall behind us. So we're going to pass 180 here. And then we want to do a branch. So this is telling us, did the line trace hit anything? Now, in the case that it doesn't actually hit anything, we're going to want to end the wall run, right? Because if somehow there's no more wall behind us, like maybe we walk, like I'll just show you an example. So if we're on, this is a good example. So if our back is up against this wall here, we can walk left and right, right? But if we go past the end of the wall, then we want to stop wall running, which is exactly what happens, right? So he goes past the end of the wall, there's no more wall behind him, and so we want him to stop wall hugging. I think I said wall running again. we want him to stop wall hugging. So let's just make a little function over here to handle that. So let's make a function. We're just going to call it end wall hug. And then we're going to make this private. And then we're not actually going to fill this out yet. We're going to do that later. I just want to have it so we can call it. So if the line trace behind us doesn't hit anything, we're no longer on a wall. So let's just go ahead and end the wall hug. I spelled wall wrong. There we go. Okay. But in most cases, this is going to return true because we're going to be up against the wall. So what we want to do is we want to take this value and we want to break it. And then we're going to hit this little button to expand it. And we want to save the wall normal. So let's take this normal and we're going to promote it to a variable. Actually, let me check one thing in my other project real quick, because I made this a public variable. Yes, okay, it does need to be public because we're going to use it inside of the movement code. So make it a public variable just like I did. We can make it private though. And then we're going to call it the wall normal. So this is the normal of the wall that we are currently up against. And this is going to be very helpful for us to know. So we're going to use this wall normal to, like I said before, we're going to use it to both continuously make sure that our back is against the wall, meaning we don't get too far away from the wall. So if you remember, if we're on these pillars right here, and I go to the left too far, my character actually moves back so that his back is always on the wall, right? And then we also want to make sure that we're always facing perfectly away from the wall, because as we go around corners, we want to make sure our wall or our face faces away from the wall. So that's the two things we're about to do. So let's do the distance one first, where we make sure our back is totally against the wall. So to do that, we're actually going to use a capsule trace to check if there's any room available behind us. So we can drag in our owning player here, and we can say get capsule component, like so. And then from this, we want to actually let's first say right click capsule trace by channel, because this is actually what we're going to do. So then we can fill it out. So capsule trace by channel. So our start location is going to be the location of our capsule. So we'll say get world location. And so this is going to be our start location. We're going to need a little bit of room here. That's why I'm just dragging this over. Our end location is going to be our start location minus the wall normal. So we'll say minus the wall normal. So get wall normal. This might be a little confusing to people, but we're basically just saying do a capsule trace in the opposite direction of the wall's normal. And we're actually not multiplying this value by anything, because we only want to do a tiny little trace just to see if there's any little room behind us. Because if there's even just like an inch of room behind us, then we want to try to move back to fill in that space. So that's why we're not multiplying this by anything. But we're basically just doing a capsule trace back like towards the wall essentially. And so that's going to be the end location. And then the radius and the half height we can get from the capsule as well. So we'll say get scaled capsule half height. Oh, sorry, that's the height. And then for the radius, we want to say get scaled capsule radius. For the trace channel, we can set this to our wall trace channel that we made earlier. And that should be all we need to do for that. And so what we want to say is we want to do a branch off of this return value. So this is going to return if the trace hits something. So if the trace hits something, then we know that there's no room behind us at all. But if it doesn't hit something, then we know that there is room behind us. So we want to actually try to move our character back to fill in that space. So I'm actually going to do a not win here, just to flip this around. And then since there is room behind us, we want to drag in our owning character. Now we're essentially going to simulate like he's pressing the back button to move towards the wall. So we're going to say add movement input, and the world direction is going to be our wall normal. And then the scale value is going to be -1, because we want to move in the opposite direction of the world normal. Okay, so let's go ahead and give this a try and see if this works. I'm just double checking to make sure this is correct. Yeah, I think this is good so far. So let's add some geometry here. I'm just going to go to create and then add in a cube. If you're in an older version, it's like there's a window on the left where you have to drag in objects, but it should be pretty simple to find out. So what we want to do is we want to make a column here that sticks out of the wall, but not too much that we can't move over it. Something like that. And then let's press our E key. Oh, so we need to fix this first. Right. So right now it's like trying to pull me back to the wall, but it's not quite working yet because I forgot to do the input side of things. So right. So before we can test this, we need to actually set it up so that our input kind of behaves differently, whether or not we are up against a wall. So let's see. Let's go to our third-person character and then go to this section where you're handling the movement input. Sorry, let me go there in my other project as well. Okay, so we're going to simplify this a little bit into sort of its own function. So let's see here. Actually, let's just let's just delete all of this and we'll just rewrite it in the way we want it to be rewritten. So let's just move these over here. We can make this smaller. So we're going to make a function for handling our input. We're just going to call this handle movement input. Make this private. And then we want to say, or sorry, we want to add an input value here of type float, and it is going to be called axis value. And then we also want to take in a Boolean for whether or not this is right input. So what I mean by right input is if it's true, then we're basically pressing A or D, so we're moving right or left. And if it's false, that means we're pressing W or S, meaning we're moving forward or backwards. So let's go inside of here. So the first thing we want to do is we want to check which movement state we're in. So we'll drag in our movement state and we'll do a switch off of this. So if we're in the default movement state, then that means we're just walking around normally. So we want to do pretty much what it was doing before. So I'm going to re-add the code that we just deleted, but I'm going to change it a little bit to make it a little simpler. So we're just going to say get control rotation, and then we want to break this value, this one, break rotator, and then this is basically what was just there before, and then we're going to say make rotator, and they're just doing this so that way they can zero out the pitch and the roll, so it's only the yaw. And then we're going to say get forward vector and get right vector. And then we want to use one of these based on whether or not right was passed in. So we'll say get right, and then we'll do a select. And we want this one, the one with the little yellow thing here. So if it's true, we want to use the right. If it's false, we want to use the forward. And then finally, we want to say add movement input. And we'll make sure we hook this up to the default node, like so. And that is our world direction. Our scale is going to be the axis value that was passed in. So we'll say get, oh, sorry. Did I call it axis value? I meant to call it scale value. Call this, or just call it scale. It's fine, I guess. And then we'll say get scale. We might need to recompile for that to show up. Get scale, there it is. Okay, so now our movement should work, but only when we are on, or only when we're not on a wall. So let me make sure I did this. Oh, so we need to call it over here real quick. So just drag in the handle movement input and hook it up to forward and hook that up. And then also copy paste it down here. But make sure for the move right, you select the right checkbox. Okay, so now we should expect it to allow us to walk like we did before. So make sure walking still works. But now when we're up against the wall, we shouldn't have any input at all. So make sure that yours behaves exactly like that. You should basically get stuck on the wall when you start getting on a wall. And then we're going to write the input next so that he kind of slides left and right. And then we're also going to hook up the animation and then finish a couple more things inside of the component. And then we will be good to go. But I'm going to continue this in part 3 just because this part's getting kind of long. So I'll see you guys in part 3.